another partial fractions problem, but it also is improper. And so here's what I'm going to say before I even do this problem, which is the integral from 1 to infinity of 1 over 2x squared plus 3x plus 1. I know the integral of 1 over x squared from 1 to infinity converges. And this looks like it's actually smaller, right? Because I know that 2x squared is bigger than x squared when x is positive, right, when x is bigger than 1. And so if I add more positive things, right, 2x squared plus 3x plus 1 is bigger than x squared. And so if I take the reciprocal, the order of the inequality changes so that this fraction is less than this fraction. So if the integral of this 1 over x squared is convergent, meaning the area under the curve is finite, and this is a smaller function but still positive, there's actually a theorem called the comparison theorem that says if you have a function that's smaller than a function whose integral converges, this integral converges as well. So already right off the bat, I'm pretty sure this converges. So let's do the work. So I'm going to kind of ignore the limits to integration first and just deal with the partial fractions aspect of it. So I'm going to have 1 over, I'm going to factor this. It does factor. It factors as 2x plus 1 times x plus 1. All right, it's a over 2x plus 1 plus b over x plus 1. Multiply both sides by the common denominator. I'm going to get 1 equal to a times x plus 1 plus b times 2x plus 1. The numbers are not super nice here. One convenient value is negative 1. Make it 1 equal to 0 plus b times negative 2 plus 1 is negative 1. b equals 1 divided by negative 1, which is negative 1. And then the other convenient value is negative 1/2. Not great, but whatever. Still have 1 on the left. You get a times negative 1/2 plus 1 is positive 1/2. Multiply both sides by 2 to get 2 equal to a. So we're integrating, and actually I'm just going to do the integral over here. The integral of 2 over 2x plus 1 plus 1, sorry, negative 1, so minus 1 over x plus 1 is going to be, let's see, so the 2, ignore the 2. The integral of 1 over 2x plus 1 is the natural log of the absolute value of 2x plus 1 divided by 2. Those are going to cancel. Minus the natural log of the absolute value of x plus 1. Okay, so here's the thing. Just to double check on this, the derivative of the natural log of 2x plus 1 is 1 over 2x plus 1 times the derivative of that, which is 2. So it definitely is that. All right, so here's what we've got. We've got that this is equal to the limit as t goes to infinity of the integral from 1 to t of, I guess I could write this intermediate step. Then we know how this integrates, so we're going to get the limit as t goes to infinity of the natural log of the absolute value of 2x plus 1 minus the natural log of the absolute value of x plus 1 from 1 to t. Plug in the limits of integration. And I might have to erase over here so I can kind of fit this in more nicely. So I'm going to erase this now that I've written my integral here. So I got the natural log of the absolute value of 2t plus 1 minus the natural log of t plus 1, the absolute value. I don't really need the absolute values anymore, but whatever. Minus the natural log of 2 times 1 plus 1 is 3, minus the natural log of 1 plus 1 is 2. Natural log of 2, sorry. And I didn't write the absolute values because I know 3 and 2 are already positive. Okay, so now here's the important key step. If you just try to evaluate now, you're going to think it's divergent, which is why I said at the beginning it was convergent. So if I plug in infinity, natural log of infinity is infinity. And natural log of infinity is infinity. So I've got infinity minus infinity. But if I just thought, oh, it's going to infinity, it diverges, I'd be wrong. What you have to do here, and it's kind of a little bit of a trick, is you have to combine these. So this is the limit as t goes to infinity of the natural log of this minus, or sorry, this divided by that, right? Because when you have a log minus another log, you can divide the arguments. And you can also do it over here. You can do minus the natural log of 3 halves. Okay, now here's the thing. As t goes to infinity, 2t plus 1 over t plus 1, that's just like a rational function, right? We know how to take the limit of that. It's just 2, right? Because the degree on top is the same as the degree on the bottom. So the limit is the quotient of the leading coefficients. So this is going to go to 2, which means I get the natural log of 2 minus the natural log of 3 halves, which you could leave like that, or you could even combine it into one logarithm and say it's the natural log of 2 divided by 3 halves, which is the natural log of 4/3. All right, flip and multiply. So this integral does converge, and it converges to the natural log of 4/3. Kind of neat.